Alright, let's look at the homework 7.2, problem number 6. Alright, let's evaluate this integral. Alright, so first I'm gonna just pull 4 outside. There. Alright, oops. Outside there. Alright, so we get 4 outside. Then you have an integral from 0 to pi over 4. Alright? Alright, so it looks like you have a secant to the fourth and tangent to the fourth. We can probably leave a secant square out. So we have secant squared of theta, tangent to the fourth of theta, and I'm going to leave this secant squared of theta out here and with respect to theta. Right? So let's go through a substitution. We're going to let u be, right? We're going to let u be tangent. Right? Then let's go through the usual drill. Take the derivative of u with respect to x, which is going to be secant squared of x. Right? Oh, actually, I meant the theta here. Right? No, not x, theta. Right? Then we can take the reciprocal of both sides. And we have a d theta over du, which is equal to 1 over secant squared of theta, right? Then multiply through by du as usual. Then you have a d theta is equivalent to du over secant squared of theta. Right? And also, we have to do a conversion. Originally, theta goes from 0 to pi over 4. Right? We're going to convert it to a u value. Right? Tangent of 0 is 0. Right? Tangent of pi over 4 is 1. So u goes from 0 to 1. Right, so this is going to be equal to 4 was already there, and the integral from 0 to 1. Right, then here, since we're using tangent as a substitution, I'm going to rewrite the secant squared as 1 plus tangent squared. Right, so here 1 plus tangent squared would be, since tangent is u, it's going to be 1 plus u squared. Right, then tangent to the fourth, so u to the fourth here. Right, and I'm going to leave secant squared of theta alone, and the d theta is same thing as du over secant squared of theta. Right? So we can cancel secant squared of theta on top, secant squared on the bottom. Right? Then I'm going to go ahead and distribute u to the fourth to 1 and also u squared. So we get 4 times integral from 0 to 1 and u to the fourth plus u to the 6th power with respect to u. Right? Then this is equal to 4 times antiderivative. This is just going to be a power rule. U to the 5th power over 5 plus u to the 7th power over 7, and it goes from 0 to 1. Right? Then you plug in 1, you get 1 over 5 plus 1 over 7. And if you plug in 0, it's all 0. 0 to the 5th is 0, 0 to the 7th is 0, so this is all we get. Right? Then we can probably take the common denominator. 5 times 7 is 35. And so we have to multiply by 7 and multiply by 5. Right? So this is going to be 4 times 12 over 35. So this is 48 over 35. Right? And so that's the value of the definite integral. Alright, so let's type it in. We got 48 over 35. Alright, submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.